All right, so welcome to exercise 5E. So this is for quartiles and outliers. The lesson intention for today is to know how to calculate the different quartiles, to calculate interquartile range and its meaning, and to be able to identify the outliers, and of course success criteria to be able to do those different things. We'll skip the chili time for today, just so we can go straight into the bound reference notes. So I'll get you to write all of these in, but in the meantime, I'm going to explain each one. So with the data that you have quartiles, and quartiles right here, quartiles comes from quarter, okay? And then with quarter, we know that we're going to split it up into 4 different parts. So we have the set of data, and then we are going to be splitting them up into 4 different parts, okay? When we have the lower quartile, it means it's going to be the first, it's going to be in the first part of the data set of the 4 parts. So it'll be the median of the lower half of the ordered data. So then you're going to have the upper quartile, so Q3, and it'll be the median of the upper half of the data, and and then you'll have the median as well of the whole thing, right? We know that we have the median just from the last lessons, that median is the middle of all of the data set. Next, you have the interquartile range. So it's just going to be the difference between Q3 and Q1 right here. So it's going to be, when you look at the data, it'll probably be the majority or the big chunk of the middle of the data. And then lastly, we have the outliers. So if there are numbers that are outside of like the majority of the data, then they are going to be the outliers. And the way that you calculate the outliers is trying to put a fence in your data, and then any numbers outside of those 2 different fences are going to be the outliers. So when we consider the data, just like what we were talking about with the whale effect, we want to try to get rid of numbers that skew our majority of our data a little bit too much. Okay, so I'll give you guys just 3 minutes. We'll take a pause here, 3 minutes to write down this stuff in your bound reference notes. Okay, so welcome back. We'll go on to the worked example now. We're going to have a couple of sets of data to apply this knowledge to. All right. So the first thing is you need to know if there are how many numbers there are in your data set. So the first set of worked examples that we have is when we are going to be doing it with odd numbers of data. So odd numbers of data that we have in the I do, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers here. Then what you want to do is you want to find the median number. So the median, remember that we said, was the middle. So if we go through the middle, this is actually a way that you guys can do it. You divide it by 2, and then it's going to be that next number that you have. So if you divide 13 by 2, that's going to get 6.5. So it'll be the 6.5 per se is going to be that middle number. So we're going to go 1, 2, 3, 4, 5, 6, and then the 0.5. So right here is going to be that middle number. So 6 is going to be the median. Now we can test this out just like what we did before when we did the tick method. So tick, 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 tick. And once we've ticked it, we have 6 there in the middle number. Okay, so that's the way that we can do it. So what I'll do is I'll actually write that down. So 13 divided by 2 is 6.5. Therefore, the median 7th number. Okay. All right. Next, what we have is we are going to do our Q1. So we don't consider the median, but we are just going to, with the Q1, I'll actually highlight it. We are considering these numbers right here. Okay. So then what's the middle number in with these numbers? It's actually these two numbers. So we'll do 3 plus 3 divided by 2. So the answer is going to be 3. Okay. And then for the Q3, let's look at these numbers here. And then the same thing, the two middle numbers are going to be, whoops, not those two. Oh no, yes, it is those two. Those two right there. So it'll be 9 plus 9 divided by 2, and it'll be 9. So I think that's just coincidental. But when you have the two numbers as the medians, just like what we had with the normal median of the whole data set, you find the average between the two. So the interquartile range is going to be your Q3 minus your Q1, so your two different medians. So Q3 was 9 minus your Q1, which is 3, and that is equal to 6. So your interquartile range is 6. The lower fence is, the lower fence is your Q1, which is 3 minus 1.5 times your interquartile range, which is 6. Now remember, what we do need to do is follow BODMAS. We need to follow BODMAS, so we're going to do 1.5 times by 6, so that's 9. And you're going to do 3 minus 9, so it's going to be negative 6. And then the upper fence is your Q3, which is 9 plus 1.5 times 6. So you're going to do the same thing, the 1.5 times 6 first. So 1.5 times 6. 1.5 times 6, is 9. And then you do 9 plus 9, which is 18. So what these numbers are telling us is if there are any numbers in our data set, so right here, that is less than negative 6, or it's going to be more than 18, that means they are outliers. So they are affecting our averages too much, or our data set. And if we have a look up here already on the top, there's no numbers that are less than negative 6, but there is a number that is more than 18. So we would actually say that this is an outlier right there. So I'll put a note down. We're not doing it this week, but that is indeed an outlier. So outlier. All right. The next one we'll do together, and then you'll do the you-dos by yourselves. So the lower quartile, so let's find the median first. So the median with these numbers, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So that means it'll be, so 9 divided by 2 is 4.5. Therefore, fifth number is going to be the median. So 1, 2, 3, 4, 5. 8 is your median. And then when we're looking at the quartiles, so Q1 is going to be these numbers. So these are the two middle ones. So it'll be 2 plus 3 divided by 2. Your Q1 is then going to be 2.5. And then you're going to do your upper quartile. So your upper quartile are these numbers here. These are your two middle numbers. You'll have 10 plus 10 divided by 2 because they're the two middle numbers, and it'll be 10 there. Our interquartile range, just like what we had a look over here in this example, is your Q3 minus Q1. So it's going to be 10 minus 2.5. Interquartile range is 7.5. And then the last two that we're doing are the lower fence and the upper fence. So lower fence is going to be Q1, so 2.5 minus 1.5 times by 7.5. And if we do that in our calculator, keeping in mind we have our BODMAS, then the answer is going to be negative 8.75. And then same thing that we're going to do with the upper fence, but this time it'll be plus. So our Q3 is 10, so 10 plus 1.5 times 7.5. So it'll be 10 plus 1.5 times 7.5. It'll be 21.25. Those are the lower and the upper fences. So I'll give you guys 5 minutes. We'll pause right here. I'll give you 5 minutes to do the you do here for me, please. All right, welcome back. So now what we have is very similar things. Let's find the median first, so that's going to be easier for us to actually find our Q1s and Q3s. So how many numbers are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 as well, which means the fifth number is going to be the median. 1, 2, 3, 4, 5. 3 is the median. Our lower quartile, or our Q1, okay, are these, which means the two numbers are here. 1 plus 1, 1 plus 1 over 2 is 1. Now, I know that they're both the same numbers here, but what we're doing is we're practicing the process. So regardless of what number that you have, you know how to actually do it. And then next we have the upper quartile, so Q3. So it will be, Q3, so we're doing here. So we have 4 and 5. So right here we have two different numbers. So it'll be 4 plus 5 divided by 2. So it'll be 4.5 for the Q3. Interquartile range is Q3 minus Q1. So it'll be 4.5 minus 1, and the answer is 3.5. And then lastly, we have the lower fence. Lower fence is 1 minus 1.5 times by your interquartile range. So right here, 3.5. So if we put that into the calculator, 1 minus 1.5 times by 3.5, it'll be negative 4.25. And then upper fence is the opposite of that. So Q3 is 4.5 plus 1.5 times 3.5. 4.5 plus 1.5 times 3 times by 3.5 is 9.75. Okay, so these are the odd numbers. It's going to be very similar now with the even numbers, but it's just going to change where the medians are going to be. So what we'll do the I do example, and then you can go straight to the you do example. So we'll go down looking at the even numbers now. So these are, if you have even number of the data, or a data set that has even numbers.